In this video, we will discuss two special properties of a gyrator. First property is when an inductor is connected at the output port of a gyrator, then this combination is equivalent to a capacitor. See, in this circuit, we have a gyrator and we have connected an inductor at its output port. According to the property of gyrator, this part of the circuit is equivalent to a capacitor whose value is suppose C. So in the first part of this video, we will prove that this part of the circuit is equivalent to a capacitor, and then we will calculate the value of this C in terms of alpha and L. In the second part of the video, we will see that similar to the inductor in the first part of the first circuit, when a capacitor is connected at the output port of a gyrator, then this circuit is equivalent to an inductor. Again, here we will calculate the value of L in terms of C and alpha. So let us start with the first circuit. For gyrator, we know that the defining equations of a gyrator are V1 is equal to minus alpha I2 and V2 is equal to alpha I1. These two equations are representing this gyrator. For this inductor connected at the output port of this gyrator, suppose if we have an inductor like this voltage is V2 and this current is suppose I2 dash, value of inductor is suppose L, then we can write V2 is equal to L dI2 dash upon dt. Here the value of this I2 is opposite to that of I2 dash, so we can say I2 dash is equal to minus I2. So this can be written as V2 is equal to minus L dI2 upon dt. If I combine this equation with these two equations, then I will get, let us put the value of V2. V2 is equal to alpha I1. So I can write alpha I1 is equal to minus L I2 I can calculate from this equation, and I2 is equal to minus V1 upon alpha. So I can write D minus V1 upon alpha upon dt. This minus 1 upon alpha is a constant and I can take it outside. So it can be written as alpha I1 is equal to L upon alpha dV1 upon dt. Or it can be written as I1 is equal to L upon alpha square dV1 upon dt. Now see, if we have a capacitor whose terminal voltage is equal to V1 and I1 current is flowing through that capacitor, then the relation between I1 and V1 can be written as I1 is equal to C dV1 upon dt. We can see that this equation is similar to this equation which is obtained for this gyrator and inductor combination. So we can say that since this equation is similar to this equation, we can say that this circuit is equivalent to a capacitor and the value of capacitance is equal to L upon alpha square. C is equal to L upon alpha square. So we can say when an inductor is connected at the output port of a gyrator, then this combination is equivalent to a capacitor and the value of capacitance is equal to L upon alpha square, where alpha is a gyration constant. Now come to the second problem, that is when a capacitor is connected at the output port of a gyrator, then it is equivalent to an inductor. Here also, first of all, we will write the defining equations for the gyrator, that is V1 is equal to minus alpha I2 and V2 is equal to alpha I1. For this capacitor, if the direction of current is this and suppose the value of is I2 dash, then we can write I2 dash is equal to C dV2 upon dt, and since I2 dash is equal to minus I2, we can write I2 is equal to minus C dV2 upon dt. Now we have to prove that the combination of these two equations and this equation will give us an equation which is similar to the equation for this inductor, that is V1 is equal to L di1 upon dt. Now in this equation, let us put the value of I2 first. From this equation, I2 is equal to minus V1 upon alpha, so we can write minus V1 upon alpha is equal to minus C, and the value of V2 is alpha I1 minus C d alpha I1 upon dt. Alpha is constant, take it outside, so we can write this minus will get cancelled. V1 upon alpha is equal to C alpha di1 upon dt, or V1 is equal to C alpha square di1 upon dt. Now we can see that this equation is exactly similar to this equation. So we can say that this circuit where a capacitor is connected at the output port of a gyrator can be reduced to an inductor L whose value is equal to C alpha square. L is equal to C alpha square. So these are the two important properties of a gyrator. That is, first property is when an inductor is connected at the output port of a gyrator, it is equivalent to a capacitor. And the second property is when a capacitor is connected at the output port of a gyrator, it is equivalent to an inductor.